Now, if you take a look at the processor, you'll see that it has notches on either side, and they're offset, to one end. And those notches have to align with special indents on the side of the socket. So basically, take a look at the socket and look at where those indents are, and drop the processor into place. There you go. Now the processor is set into the socket. However, there's still no tension on it. In order to have it fully installed, we need to drop the load plate on top of it and then kind of press it down a little bit and use this load lever to put all of the tension on it, and then put the lever underneath the retaining tab on the side. So at this point, the processor is now installed in the socket. The load plate is putting pressure onto the top of the processor so that all of the lands on the bottom are in contact with all of the pins in the socket. So it's as you can see, it's fairly simple and straightforward to install a processor. Now, if the processor is of the type that uses pins, it works very much the same way. You don't have a load plate, but you do have a lever which releases tension on what's called a zero insertion force socket. Then you drop the processor into the socket, observing the correct orientation, and then you basically close the zero insertion force lever, which then applies pressure to all of the individual pins. So whether it's a pin processor or a land grid array processor like this one, the installation is very similar. Okay, now with the processor installed, we have to deal with the heatsink. Now let's talk about heatsinks for a second. I have here the heatsink that came with this processor. Now, heatsinks are made out of usually either two materials, sometimes both. They're made out of either copper or aluminum, and this particular heatsink has both. It has a core of copper surrounded by fins of aluminum. Now, why the different materials? Well, copper is one of the best thermal conducting metals that there is. Silver is a little bit better than copper. It's like 5% better as a thermal conductor, but it costs 80 times more, so we don't usually see solid silver heat sinks. However, a solid copper heat sink would really be the best design. It would conduct the second most heat next to silver away from the processor. So why don't we see heat sinks that are all copper? Well, the problem is copper is expensive. It's a lot more expensive than aluminum. It has twice the thermal conductivity of aluminum, but it also costs from 3 to 9 times more, depending upon whether you're going by weight or volume. So the compromise is that many heat sink manufacturers, what they'll do is they'll have a copper core, like you see on this one, and then surround it with fins made out of aluminum. Some, depending upon the performance nature of the heatsink, some heatsinks might be all aluminum, or some might be all copper. In any case, that's the different types of metals that you'll see. Now, in addition to talking about that, we need to talk about what's called the thermal interface material. That's the material that basically has to go between the processor and the heatsink. Now, the thermal interface material is basically a grease or a wax type substance that make sure that that there's no little tiny air gaps, that the maximum amount of heat is transferred from the top of the processor to the heatsink. If you don't use the thermal interface material, you're compromising the performance of the heatsink dramatically. And what that'll cause is that in many cases the processor will overheat or not be able to run at its full speed, because modern processors don't actually overheat to the point of destruction or stopping. What they'll do is throttle themselves down. So you'll end up with a system that for some reason doesn't seem to be running as fast as it should be. The real reason is you don't have a good bond between the heatsink and the top of the processor. Now, thermal interface materials come in two main types. One is called a phase change material. The other is called a grease. Now, phase change material is a wax type substance that is a solid at room temperature and which then melts at somewhere over 113 degrees. So when the processor warms up, this stuff will melt and then liquefy and perform